Hi folks, today we're going to take a look at making some basic circuits in the TinkerCAD Circuit Simulator. I'm going to do a few different examples, maybe show you how some components work and how to put them together and how to use the simulator itself. So once I've signed into TinkerCAD, you should have circuits over here as one of the choices on the left-hand side. Once you've done that, you have this create new circuit button. So that's what I'm going to click on. When it first opens up, we have a few things to look at. The components over here on the right, you can start with basic. That's what we're going to start with. You can go to all to get a few more options. There are some starters, both under basic circuit assemblies that have kind of some pre-made stuff to get you started, but I'm gonna start from scratch with these. So we're gonna talk through kind of what makes a circuit and what we need to keep an eye on. Okay. So in order to make a circuit, one of the things that we're definitely gonna need is some juice, some power, some electricity, right? So we need a power supply. In our simulator over here, that's going to look like a battery. I can start with this nice 3-volt coin cell battery. This is a battery like what is in a watch, or where else might you have seen one of these? Maybe inside your calculator. So they're the little ones that are, you know, the size of a coin, hence coin cell. And they fit into these little holders, and we can connect to positive on one side and negative on the other side to create a circuit. So the first thing I'm going to do is create a bad circuit. Okay, so a bad circuit is one where we connect the positive and negative, but there's no work being done. So this is technically a circuit, right, in that it connects in a circle, like circuit, like going around a racetrack is a circuit. But this would not be anything that we would want. This has a short circuit, which means that there is a path directly from positive to negative that encounters no work at all. So if we were to start this simulation, we would see that nothing is happening. Really boring. So this is really boring, and yet it would drain our battery and do all sorts of bad things. We don't want short circuits. I'm going to get rid of that. Okay, so don't ever do that. No short circuits. There should always be work being done by your electricity. Electricity is lazy, and if it has the option to not do any work, it will do that. So we always need to make sure that every path in our circuit has work being done. So what do I mean by work? Something that causes work to be done is lighting up a light, like this LED, for example. So lighting up this LED will be an example of work being done. LEDs have 2 legs. Let me zoom in. They have this straight leg and this kind of bendy one. If we were to see an LED in person, usually that means one leg is a little longer and one is a little shorter. And so this bent one, that's the long leg. The long leg is the anode, and the short leg is the cathode. You can think of this as needing to go to positive, needing to go to negative. So let's just give it a shot. So if I connect positive to the anode, negative to the cathode. So now let's see, am I running a circuit? I'm going to leave positive, go through the LED all the way back to negative. So I do have a circuit. I have a path to follow all the way back. And let's start the simulation. Aha, my light turns on. This is excellent news. So there are a few things that I'm going to want to change about this circuit. But first, I'm going to do it wrong and show you what that looks like. So when I have components out here, you can see that as I hover over the endings, it tells me what those endings are. Those are also what I'm going to click on when I want wires to connect things. So I'm going to connect this LED backwards this time. I'm going to send the anode down to the negative, and I'm going to send the cathode over to the positive. So it looks like I'm in good shape. I do have a circuit. I go out the positive, through the LED, back to the negative. That part's good, so I'm doing work. But what happens when I run this? No light. Nothing good. That's because LEDs are directional. They only will allow power to flow through if you connect them the right way. So it's always good to check that your LEDs are connected with the anode going to the positive and the cathode going to the negative. Okay, so if I run this simulation again, we can see that the light turns on, but you also get this little exclamation point. And if you hover over that, it says current through the LED is 61.9 milliamps, while recommended maximum is 20 milliamps. The usable lifetime of the LED may be reduced. That means in the real world that this would just not light up for very long before it stops working. So let's see if we can fix that. Let's pull out a resistor. A resistor, you can hit R to rotate objects. A resistor I could put on either path, and its job is actually just to slow down what's going on. It's not going to change the voltage available in the entire circuit, but it's going to help protect this LED. Okay, so let's see. Right now, it has 1 kiloohm of resistance. Let's see if that comes out about right. So now you can see that my LED turns on, but I'm not getting that warning anymore. It's also a lot dimmer than it used to be. So let's see if we can change this value. 1 ohm is probably going to be too low. Let's try 100 ohms and see how we do. Okay, so it's a little bit brighter, and we're still not getting the warning. So it looks like this 100 ohm resistor is doing a good job protecting this LED. So far, so good. But this circuit would not be super useful because as soon as I plug in the battery, that LED is going to be on all the time. It's not probably what we want in the real world, right? We probably want to be able to turn it off. So for that, we might want a switch or a button. I'm going to try the switch first. So I'm going to bring out a slide switch. Zoom in on it a little bit here. So a slide switch, like a light switch or a little toggle that you can imagine sliding back and forth. When you slide it in one direction, it stays there until you go slide it back the other direction. And so if I hover over the possible connections at the bottom, I have terminal 1, common, and terminal 2. So I'm going to change the wiring I've got here, and I'm going to connect my LED to one side, and I'm going to connect the common to the other side of the battery. All right, so now if we look at the possible path for the electricity to follow, it's going to start out here, go through the resistor, go through the LED, and make it to the switch. If the switch is engaged, which it is right now, it will continue through and go back and complete the circuit and go back to the battery. If the switch is not engaged, it's slid the other direction, it will start out here, go through the LED, and dead end. Can't go anywhere. So the light will not turn on. It will not be a complete circuit. Okay, so I'm going to start the simulator. You can see that the light is on. If I slide this switch, the light turns off. That's because the power is trying. Oh, dead end. Nope. Nowhere to go. So no way to complete the circuit and light the light. As soon as I slide this back, now it has a path to complete that circuit, do its work of heating up this resistor a little bit and lighting up this LED. All right, so this is an example of a light controlled by a switch.